Hello. Today, before we get into the categorical syllogisms that we're going to mainly cover this week, we should finish up our discussion of immediate inferences. So last time we did one form of an immediate inference with the contradictories using the modern square of opposition. Now remember, again, with immediate inferences, what you're working with is an argument that has one premise and a conclusion. And what you're trying to figure out with these immediate inferences is whether or not you can get a valid or invalid argument. So if, for example, last time, if two propositions were contradictions of each other, they were true contradictions of each other, then if you said, for instance, that all A's are B's, therefore it is false that some A's are not B's, then that would be a true statement because you could tell from the square of opposition that those two cannot be true at the same time. So that would be a valid argument. Now this week we're going to finish up sort of the discussion of immediate inferences by covering three forms of inferences here: conversion, obversion, and contraposition. Now with all of these inferences here, we don't need to know any sort of facts about syllogisms. We can just, by knowing the relationship between certain categorical claims, we can determine whether an argument is valid or invalid. Remember again that if you have a true premise and then the conclusion is true, that's a valid argument. But if the premise is true and the conclusion turns out to be false, then we will have to say that that is an invalid argument here. All right. So when we are doing conversion on two propositions, or on a proposition, what we are doing is we are switching the subject and the predicate terms. So let's begin with the A propositions we covered last time, those universal affirmative claims. So if your initial proposition is all A are B, then if you convert that, it becomes all B are A. So for example, if you have something like all cats are mammals, converting it will involve then saying all mammals are cats. Now, if we think about the nature of these claims, the truth value of these claims, and we map out with the Venn diagram what these propositions look like, we can see then that these two propositions, the conversion of A, they're not logically equivalent propositions, meaning that they do not have the same exact truth value. And we can see this also isn't going to give us a valid argument, because it's true to say that all cats are mammals, but it would be false to say that all mammals are cats, obviously, here. So when we're looking at these two propositions, given the Venn diagrams here, we would say that after conversion, when it comes to A propositions, we have different truth values. Right. Now, if we look at the E propositions here, then, we see a different sort of relationship. So, again, to sort of give an example here, if we say no cats are reptiles, and then we convert that to say no reptiles are cats, we'll see then that when we map each of these individual propositions out with a Venn diagram, that they are going to be shading out the same area. So that basically you can think of it this way: if you find a cat, it will never be a reptile, and the conversion here says if you find a reptile, it will never be a cat. And of course we know that both of these claims are true claims, and in fact they both have the same exact, they map out identically on the Venn diagram. So when it comes to conversion with E statements, then we can say that the original claim and the converted claim are logically equivalent. So let's consider the particular claims here, the I and the O claims. Okay. So if we're doing the I statement here, of course, to recall, then this basically says some A are B. So when we map that out, to remember here, we're saying that there is at least one individual who is both an A and belongs to the class of A and the class of B. Now, if we have another claim that's, if we convert this claim and say some B are A, then we also know that you're saying here that something in the class of B is also in the class of A, and so once again we have an X within the overlap here. So again, to kind of give you an example here, some dogs are brown animals. If you convert that and say some brown animals are dogs, these are both true statements, really. Okay. And they both are shading in the identical areas of the Venn diagrams. So given this fact, we can say that the initial statement and its of the I statement, the initial I statement and its conversion are logically equivalent. Now let's consider the O statements, the particular negated statements here. So some A are not B. Conversion is some B are not A. So the idea here is if we map this on a Venn diagram, we would say that there are A's. There's at least one A. There's one individual who's in the class of A, who's not in the class of B. And this conversion here says there's at least one individual in the class of B that is not in the class of A. So to give us an example here, so some dogs are not brown animals versus some brown animals are not dogs. Okay. This goes back to some of the issues we have with distribution here and why these two are not equivalent. But the idea here is that we're going to get two different or indeterminate truth values on here. So the point here is that with O arguments then, or O propositions I should say, they will render different truth values here. Okay. Alright, so the only sorts of conversions that are logically equivalent are those that involve the E and I propositions.